All right. So dependent is when the outcome of one event impacts the outcome of another event. This is called dependent. It depends on that first event. The big thing with dependent is they will not say replace. So if it's independent, it will say you draw this, then replace it and draw this. Or you pick this, return it, and then pick this. Or it will be things that have no effect on each other at all. So like spinning a spinner and rolling a die. Flipping a coin and rolling a die. Flipping a coin and spinning a spinner. Things that have nothing to do with each other are independent. Or the word replace, return. Dependent will not say replace or not say return. And one event will impact the second event. So it says, read each situation below and determine if it's independent, and we're going to say independence I, or dependent D. ID. So we'll see. Flipping two coins results in one landing on heads and one landing on tails. So would you all say that this is independent, they don't affect each other, or dependent, it depends on the other one? Independent. Flipping coins have nothing to do with each other. One flips, the other one flips, and that's it. All right, number 2, the captain of the football team is selected, and then the co-captain is selected. Dependent. So it's like I look in here and I'm like, Leland, you're captain. He has to remove himself, and then I say, Johan, you're co-captain. So I can't pick Leland again. So that first pick and that second pick is dependent on who I pick for captain. All right, you draw a joker from a deck of cards, and then you draw an ace. Do I see the word replace or return? Nope, so it's dependent. I didn't hear. Number 4, you draw a queen from a deck of cards, replace it, and then draw a 10. Independent. When I see replace or return, it's independent. If it doesn't say replace or return, it's dependent. So like these were basically the same thing, just this one didn't say replace or return and this one did. So that's how I know the difference between independent and dependent. All right, what about the last one? A coin is flipped and a number cube is rolled. Independent, they don't have anything to do with each other. All right, so yesterday when we talked about independent, it was just whatever the probability of A was times the probability of B, and we saw the words return and replace. But dependent is the probability of A, so that's still the same. But the probability of B will only happen after A has happened. And that may affect what I'm looking for. So we'll have to be very careful with dependent. All right, so some of these have pictures, some of them don't, just like independent did yesterday. The first 2 have pictures, so hopefully it'll help you understand a little bit more of where dependent's coming from. So these are like similar questions we did yesterday, but it says use your understanding of independent events and dependent events to answer the questions below. So it says Neil goes to the pet shop and selects a treat for his dog. So there's a box there for his dog. All this stuff's in that box. It says he chooses one and then chooses another. What is the probability that Neil selects a bone and then a ball? Would you all say that this is independent or dependent? Does it say replace or return? No, guys, that's what I want us to be looking out for. That's why I started here. If it says return or replace, it's independent. This does not say he chooses one, returns it, and chooses another. That's not there. So this is dependent. So it's going to depend on what he picks first. So it says, what is the probability that Neil selects a bone? So let's look here. There are 1, 2, 3, 4, 5, 6, 7 total items, right? What is the probability he would pick a bone?
3 out of 7.
3 out of 7. You ready? All right. Here's the bone. See the bone right here in my hand? He says, I'm buying this bone. He throws it in his cart. This bone is no longer there because he just put it in his cart. Because he's not replacing it. He's keeping it. Now they say, okay, wait. He's like, I also want to try to get a ball. So he puts his hand back into the basket of stuff at the pet store and says, oh, I want to get this ball. What is the probability he now picks a ball? 1, 2 balls out of 6. 6. Because when he picked this bone and he threw it into his cart, now there's only 6 things left in that basket. So dependent will remove the first item out of there. So when I take that bone out, I now only have 6 things left to choose from. And I find the probability of a ball. So there's 1, 2 out of 6. So then I'm going to take my calculator. And guys, we're not helping you with your calculator on test day. You need to know where the ABC button is. So I hit 3 ABC 7 times 2 ABC 6. And then I hit enter, and the probability of getting a bone and then a ball is 1 out of 7. All right, let's look at number 7. Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? So she's going to get polka dot both times. Is this one independent or dependent? Huh? Dependent again, because does it tell me that she's going to return or replace it? No, so it's dependent. All right, so here's her box of candles right here. How many candles are in her box? 5. Okay. All right, she puts her hand in that box and she says, I hope I pick polka dot. What is the chance that she's going to pick polka dot? 1, 2 polka dot out of 5. Oh, here's her polka dot candle in my hand. Look at it. Look at it. I'm sticking it in my cake. And then she goes back to the box. This candle's on her cake now. She goes back to the box. What is the probability she's going to pick out polka dot now?
1 out of 4.
There's only 1 polka dot left out of 4. And then I just use my calculator. 2 ABC 5 times 1 ABC 4. And I get a probability of that happening to be 1/10. So hopefully we can see from these 2 examples that on dependent, look at the denominator, look at the bottom. The first one is out of the total. The second one is always out of 1 less. The first one's out of the total. The second one's always out of 1 less. Do you all see that? So dependent changes what it's out of because they don't put it back. Independent, it would always be out of 7 both times or out of 5 both times. All right, let's flip it over. And all the questions are going to go about this laundry basket here. Okay? Okay, so it says, Mrs. Moore is doing laundry and has various pieces of clothing in her laundry basket. So let's count how many things are in her laundry basket. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So she's got 16 total items in her laundry basket. It says, what is the probability of selecting a top, so a shirt, and then selecting a bottom, so something to wear on the bottom? All right, so I'm going to find the probability of selecting a top and then a bottom. Am I going to replace it? No, this is dependent. All right, so let's count. How many tops are there? How many things can you wear on the top of your body that's in this laundry basket? 1. There's only 1 shirt. So I'm going to pull 1 shirt out of 16 items. It's dependent. So after I pick my shirt, look, here's my shirt. I'm putting it on my bed because I'm going to put it on in a second. And I go back to the laundry basket. How many items are in the laundry basket now? 15. How many of them are bottoms? 1, 2, 3, 4, 5. So there are 3 pairs of jeans and 2 skirts. So the probability of picking a bottom is 5 out of 15 because I only have 15 items now because the shirt's on my bed. And then I'm going to use my calculator. 1/16 times 5/15, and I get 1/48. All right, let's look at number 9. What is the probability of selecting a striped sock, replacing it, and then selecting another striped sock? So they want to do a striped sock and a striped sock, but this one is called independent because they're replacing it. All right, so how many striped socks do I have? 5. 1, 2, 3, 4, 5. So 5 out of 16 are striped socks. Look at me, I'm waving my striped sock. Where am I going to put it? Replacing it. So I'm putting it back in the basket. So I still have 16 items in the basket. I'm like, wait a second. No, I needed to keep that. So I put my hand back in the basket. What's the probability I'll pick out a striped sock? 5 out of 16 again. Because I replaced it so the number on the bottom stayed the same. Dependent always gets 1 less. So now I'm going to use my calculator. 5/16 times 5/16. No, you have to multiply. So 5 times 5 is 25. 16 times 16 is 256. And that doesn't reduce, so it's just 25 over 256. All right, let's look at number 10. What is the probability of selecting a towel, replacing it, and then another towel? So they want to know towel both times, but I'm replacing. All right, so what is the probability that I would pick a towel out of this? There's only 1 towel, so 1 out of 16. I'm holding up my towel, I'm waving it like a flag, and I'm putting it back in the basket because it tells me to replace it. And then I'm like, wait, I probably should have kept that. What's the probability I just pull the towel back out right away? 1 out of 16 because I put it back. So 1/16 times 1/16 on my calculator. 1 times 1 is 1. 16 times 16 is 256. All right, and then number 11. What is the probability of selecting a skirt and a top one after the other? So they want to know the probability of a skirt and then a top. Is this one independent or dependent? Dependent because it does not tell me to replace it. So that's how I know it's dependent. So what would be the probability that I would pick a skirt? There's only 2 skirts. So 2 out of 16. And then I am not putting it back because this is dependent. It doesn't tell me to replace it. So here's my skirt. I'm throwing it behind me on my bed because I'm about to put it on. What is the probability I pick a top? 1 out of 15 because the skirt's on my bed. So I'm reaching back in the basket. Now there's only 15 items there. And I'm trying to pull out a top and there's only 1 top in the whole basket. So 1 out of 15. Then 2/16 times 1/15 on my calculator. And I get 1 out of 120. All right. What's an odd number?
25.
Okay, but what makes the odd?
It's not even.
Okay, so it's not divisible by 2. So odd numbers. 1, 3, 5, 7, 9. What about even numbers? 2, 4, 6, 8, 10. What about a number divisible by 5? How would I find numbers that are divisible by 5? How about divisible means dividing, but if I want to find numbers that are divisible by 5, just count by 5. 5, 10, 15, 20, 25, 30. If I want to find numbers that are divisible by 3, 3, 6, 9, 12, 15, 18, I count by 3. If I want to find numbers divisible by 6, 6, 12, 18, 24, I start counting by 6. You're not going to do number 5. So when you get it, put a line through number 5. So this is our last homework we're going to have for a little while because we've got study guide tomorrow, test on Monday, and then I Learn starts on Tuesday. Well, you'll still have to take it. Alright, so this is our homework. Our homework, you crossed out number 5. So we're crossing out number 5 on the homework.